Hi everyone, Mr. Lansing here, and today we are going to continue with our topic on graphing rational functions. So our objectives for today are the following. The first one is to solve for the x and y intercepts. We are looking for these vital points before we formally graph rational functions. Secondly, we'll also be graphing the asymptotes, the holes or discontinuity of the graph if it exists in the function, and well, once we found the intercepts, we'll also be graphing them or plotting them in our rectangular plane. Okay, so as a short recall, last week we talked about finding the vertical and horizontal asymptotes. So those will be very important when we're going to graph rational functions manually. I believe we have an idea on what to do with our topic today. So like any other functions that we talked in the past, today we're going to solve for the x and y intercept, and these are the points that the graph touches the x and the y axis. So for the x-intercept, we're going to set y equal to 0 and solve for the value of x. So once we found the value of x, we'll be setting up the coordinate of the exact location where the graph touches the x-axis. Okay, and then secondly, we are going to look for y-intercept, and the steps to find y-intercept is to set x equal to 0 and solve for the value of y. Once we found the value of y, then we have the coordinate of the point where our graph touches the y-axis. That will be 0 paired with the value of y. Let us start with example number 1. The function is f of x equals 1 over x. This is the simplest of all rational function, and this is also considered the parent of any rational function. So let's rewrite this into the form y equals 1 over x. So now we're going to solve for the x-intercept. So for x-intercept, we're going to set y equal to 0. So we have 0 equals 1 over x. Now, when we have this equation, we can put 1 as a denominator, and we can cross multiply this or find a cross product, giving you x times 0, 0, and 1 times 1 equals 1. Since 0 is not equal to 1, then there is no x-intercept happening in this rational function. So the graph will not touch the x-axis. So our y-intercept, on the other hand, we're going to solve for y when x is set to 0. So you have y equals 1 over 0. We have, again, by doing the cross product or cross multiplication, we have this is over 1. This is 1 times 1 equals 1, and y times 0 equals 0. And in this case, there is also no y-intercept, which means the graph of the function is not touching our y-axis. Going over example number 2, where we are given the function f of x equals x over x squared minus 9. So let's set first the function to the form y equals x over x squared minus 9. So take note that f of x means the same thing as y. Now we're going to solve for the x-intercept, and this happens when y equals 0. So 0 equals x over x squared minus 9. So again, this side has a denominator of 1, and we can do the cross product. So x squared minus 9 is a quantity times 0. So 0 times x squared minus 9 equals x times 1, or 1 times x. So you don't have to really write this in your solution, but then just have to emphasize this because everyone knows what is going to happen. So this is a whole quantity, becomes 0 equals 1 times x is x. Therefore, we have an x-intercept at a point 0, 0. When the value of x is 0, the y value is also 0. On the other hand, our second part, which is to find the y-intercept of the function, we're going to set x equal to 0 this time. So we have y equals 0 over 0 squared minus 9. So we have 0, and 0 squared is 0, minus 9 is negative 9, and 0 over any number, in this case 0 over negative 9, becomes 0. So our y-intercept also happens at 0, comma 0. Now we're going example number 3 this time. Now the first thing that we need to do is to set our function in the form y equals x plus 1 over x squared minus 4x minus 5. If we're dealing with complex rational functions, first thing that we need to do is to simplify if we can simplify them. So now we can simplify this into x plus 1. If we're going to factor our denominator, that will give you x plus 1 paired with x minus 5. So x minus 5. And since x plus 1 and x plus 1 is a common factor, we can reduce this. So what's left now is 1 on top. Our new function this time is y equals 1 over x minus 5. I believe that once we know that once we cancel one of the factors of the rational function, there exists a hole in the graph or a discontinuity in the graph. But that's not our focus today. Our focus is on finding the x and y intercept. So since we've simplified our function, we'll be using the simplified form y equals 1 over x minus 5. So it's always easier and simpler if you use the reduced function. So we now have x-intercept set y equals 0. So 0 equals 1 over x minus 5. And this is over 1. And doing cross multiplication, this gives you 0 equals 1. And they are not equal, so there is no existing x-intercept. Y-intercept, on the other hand, using the simplified version of the function, y equals 1 over x minus 5. We're going to set x values to 0. So we have 1 over 0 minus 5. In this case, y is equal to negative 1 over 5. So negative 1/5 is the value of y when x equals 0. So the coordinate of our y-intercept should be at 0, negative 1 over 5. Okay, so again, there is no x-intercept, but there is an existing y-intercept in this given function. So I'd like to emphasize this one more time, that if we're given a rational function, they are factorable, please factor, and if we can reduce the function before we will find the x and y intercept for us to have the more appropriate answers.